Hello everyone, I'm just waiting for Aaron to join. Aaron says he joined, but I don't see him here. That's weird. Okay, he said he's gonna re-enter. Let's see. What happened to Aaron? Can I find him? I cannot find him. Where did he go? This is super weird. I cannot see you.
How's it going, Daniel?
Hello, I'm looking for Aaron. Where is he?
It'll happen. It'll happen.
Oh gosh.
While he joins, just wondering what papers do you have in mind?
We've chose a few papers for the past week, maybe like about 5 to 10 papers. Yeah, about 5 papers or so. Like the meta paper, there's a couple other papers, the anthropic paper. Yeah. Wait, maybe he's joining from his. Let me see. Is he joining from his phone, from his laptop? Maybe if he's joining from the laptop, it's not working. Because I always have problems when joining from my laptop, so maybe that's what it is. He said he's joining from his phone. What?
But you're on from your laptop, right?
No, I'm on my phone. Because I don't trust it on my laptop, so I joined from my phone as well. Huh. Otherwise, worst case scenario, I just have to like try to remake the space, or he has to make the space instead. Oh, finally I see him. Come on, Aaron. So maybe it wasn't working from his phone and it's working from his laptop. I don't know. Okay, I invited you to.
That's crazy.
Okay. Hello, Aaron.
Hey guys, can you hear me?
Yes, finally.
I'm so sorry.
No worries. That's. I don't know why this. Yeah. It's funny because for me, usually it doesn't work from my laptop and it works from my phone, but it sounds like for you, it's the opposite. So.
I see, that makes sense.
Okay, I guess we'll get started then. Now that Aaron is here. So yeah, like me and Aaron was just like we should talk about papers, and we wanted to do a space. So yeah, I guess we will get started. Aaron, did you have anything you wanted to say before we get started?
And nothing in particular. Let's see how this is gonna work. This is my first time to do space.
Yeah, yeah. So yeah, it should be interesting, I guess. uh, Yeah, so I mean, I guess we'll start the first paper. We have a few, yes, we have a few papers on our list. Aaron, did you want to start with a paper, I guess, or any particular paper you want to start with?
Like, what's the paper you found most interesting from last week? I mean, this week.
I mean, I think the Chameleon paper was pretty interesting. And then of course the images that sound paper was kind of unique. Those are the two ones that I thought were interesting.
Mm-hmm. Yeah. Let's start with Chameleon then.
Okay, yeah. So let me just put that up on the space so that people know what we're talking about. So let's see here, Chameleon. So this is the paper from Meta. Let's find it here, Chameleon. And I'm going to share it to the space, so you guys should see it on the top in a couple moments. But basically, yeah, this is a paper from Meta a week ago where they shared their work on multimodal foundation models. It's that they call Chameleon. It can generate and understand text and images together in any sequence, so you can have it interleaved. You can have some text, you can have some images associated with it, maybe ask a question about it, you can ask it to generate images. And I think the largest model that they had was a 34 billion parameter model, but I think they also had a smaller 7 billion parameter model variant as well. And yeah, it's the architecture is basically one big transformer, and the images are processed with a tokenizer. So they trade a tokenizer for their images, and so the images are processed as the image patches are processed as tokens, and yeah, so everything is done auto-regressively with tokens, and it was trained on about 10 trillion tokens of interleaved text and images, and it outperforms like other multimodal models like Flamingo and Idifix, and so Flamingo was like the Google DeepMind one. Idifix is like the Hugging Face one. Also outperforms Lava 1.5, which is published by some academic group. I don't remember where now. And also it's like good at text-only tasks as well. So like outperforms Mixed-Modal and Gemini Pro. Yeah, and then they talked about it's like kind of a model training paper. So they talked about all the like trading techniques they used, and they had to worry a lot about, for example, trading stability when they're trading at this large scale. So they had to use different tricks for that, because they were having issues with divergences. So the loss wasn't very stable. So they had tricks like using QK norm or Z loss, and so they talk a little bit about that as well. And so they had that also led to some architectural changes to their model that in order to deal with those stability issues. But yeah, that's my brief summary of it. Aaron, anything you want to add?
Yeah. So importantly, this model is early fusion model, meaning, well, it's like a few model, or maybe GPT-4o is also using this architecture. Unlike the architectures that were popular before these models, like maybe Gemini was kind of like that before. Likewise for GPT-4 Vision, the recent trend is early fusion, which tends to perform better, and it makes more sense for interleaved modalities. And by the way, for training these models, actually the dataset they used were mostly about text only, or text image data, and text image interleaved data was only 10% of the whole data. And they also used two-stage training, where the first 80% of training is just the typical pre-training data. But for the later 20% of the training, half of the data was high-quality data, which presumably is similar to instruct tuning. So this two-stage training seems to be getting more and more popular. Kind of like mini CPM training, it was very successful too. So yeah, and I guess that's that trend. So that's about it, I guess. We can move on.
Yeah, and then I think I was looking at the amount of GPUs. So they said the 7B was trained on 1,024 GPUs concurrently for a total of 856,000 GPU hours, and the 34B was trained on 3,072 concurrent GPUs for a total of 4.2 million GPU hours, and that's just for the pre-training, I guess. So I guess even then the further fine tuning and alignment and all that is even more GPU hours. So it's definitely very compute intensive to train these models. Unfortunately, these models were not released open source yet. I'm hoping they will be released open source. And yeah.
Oh, Alman is here.
Yeah, I just saw that.
Right now.
Yeah, maybe if he wants to talk a little bit about the paper too, that'd be great. I invite him to speak if he wants to. Maybe not, but
okay. We can probably move on to Gemini 1.5 update then.
Okay, yeah, you can go ahead with that then.
Yeah, so Gemini 1.5 was updated last week, and so here are some notable things to know. So there's notable performance boost of 1.5 Pro across various tasks, especially math, human eval, GPQA, and especially we got 1.5 Flash, which roughly performs on par with Sonnet while costing about 10 times less price. And it is suitable for low latency tasks like assistance with video input, real-time transcription, and so on. And importantly, they also released the results of Math Specialized 1.5 Pro. And their performance was even better than updated 1.5. For example, on Math Benchmark of Hendrix, the performance improved from 67 to 80 or even 91 on Math Benchmark. And GPT-4o scored only 76 on this. So here's my, so obviously they don't have any much information on why they got this performance boost. But here are some of my ideas. Educated guess. And so firstly, according to recent paper, DeepSeek Math, and they it seems that it's possible that the math specialized version DeepSeek Math used iterative refinement of data collection, and it boosted their performance a lot. It's quite likely that Google also used something similar to it to improve the performance. And actually, DeepSeek Math, even though it's like a 7-bit model, they already achieved like a 30% just using this. So this seems like a very promising direction. And actually, there was a recent paper called Alpha Math, and DeepSeek Math and Alpha Math in combination achieves 63% on math, despite using the base model of DeepSeek called 7B. So achieving 91% does not sound so far-fetched. So despite having received very little attention, training and distilling process reward model into the generator seems to have significant impact, and not only on math, but also some other domains. This was also demonstrated on coding, and it's likely that this holds for various other conventionally difficult tasks like STEM subjects, reasoning tasks, factual generation, and agentic tasks like tool use. So yeah, also Gemini 1.5 updated report mentioned that they were using some sort of inference time tricks, maybe something related to trials and errors, those kind of processes that happen in humans solving math problems, but typically is not used in these language models. So that's about it. Is there anything to add?
So yeah, I mean, this was one thing. I think I maybe saw a tweet about this, and I don't know if you've looked into this further, but I heard something about like maybe with the math data set, there's some contamination there or something like this as well, and that may be also possible here. I don't know if you've heard anything about that or looked into anything about that.
Oh yeah, I do not know much about it. Wasn't one of the benchmarks they were trying was like they were specifically against those kind of contaminations? Actually, I'm not really familiar.
Okay. Yeah. Actually, if anyone like wants to like ask questions or something like this, feel free to like raise your hand or something, and I'll make you a speaker. So if there's something that someone wants to ask about a paper or something to discuss about the paper, yeah. Okay. Let's see. What is the next paper? Is there anything else you wanted to add? I guess on the Gemini 1.5 before we move on.
Nothing else. You can move on.
Okay. Let's see. The other paper then maybe we could talk about would be the LoRA learns less and forgets less paper. Let me put that up on the space as well. So this was a paper from Mosaic that was released about like 5 days ago. And I'll just pin this to the space as well. And yeah, so this one is an interesting paper because it was doing a study looking at comparing fine-tuning with LoRA and also continued pre-training with LoRA versus doing just regular full fine-tuning and full, and yeah, just without the LoRA. And they've observed that the LoRA in most settings underperformed the full fine-tuning, and it was not able to learn well for some of these tasks. So they mainly looked at programming and mathematics, and so they were looking at these two domains, and yeah, they found that it was underperforming, and also that they also were observing that the model maintains the base model's performance as well outside of the target domain. So that's why it's forgetting less. Yeah, I think there's been some debate about this paper specifically. So I think the consensus in the community right now is that this paper, doesn't actually do a very good comparison, and they, using poor hyperparameters and things like this. So, for example, Daniel Hahn did a tweet about this, which I'll also share, which I think is a pretty interesting deep dive about this paper. And so he's done a lot of work training LoRA models. And basically doing fine tuning of language models. And he had a few observations there. Basically, for example, he was saying that some of the hyperparameters for the LoRA model is not done well. For example, with even also like the task for code versus the task for math, they have different hyperparameters, and that's why the code performance was worse than the math performance. And so yeah, he doesn't think, for example, that these conclusions really hold up. So I think there's a lot of debate about this, and I think maybe for like very narrow tasks, in my personal opinion, like for very narrow tasks, like yeah, the LoRa is probably good enough. But I think for something like continued pre-trade, when you are trying to learn like a new domain altogether, I think it makes sense that LoRa doesn't fully learn that, but I think it's still up for debate. Maybe. Yeah, I don't know. Aaron, did you want to add anything?
Oh, not much. I think that sounds great.
Okay. Did anyone else have any thoughts on this paper? Like, if you want to raise your hand and speak.
Sorry, I had a quick question.
Yeah.
So, I don't know that much about like the interleaved modalities that you were talking about a little earlier with the first paper. Like, so usually, is it? So I looked into it. So is it that like you would alternate almost, or are there sort of different techniques to the interleaving?
Basically, it's just like it's able to. I guess it's just more like it's able to process the. You could like have, I guess, text and image in the same input, for example, or the same output, for example. It's interleaved in that way. Or is that what you're asking, or?
Oh, yeah, no, I just like was wondering, like, when you were creating that data set, like the training data set, um, like what exactly that looks like? Because is it that there's like a mix of sort of modalities? Because you did say that it does well in the text only. So yeah, I was just trying to understand that.
Yeah. Or Aaron, did you also want to say anything about this, or?
Oh, nothing in particular. Well, the thing is, so let's you can consider like a say Wikipedia article. There are text and images. Sometimes image, um, there are some images like between text, right? So you can just tokenize the text using a text tokenizer and tokenize each. You can produce patches from each images, and you can just concatenate in the natural order, and that's how then you can just process everything using single transformer. Does that make sense?
Yeah, yeah, that makes sense. Thank you. Yeah, like I was like imagining it to be a little more complicated than that. So yeah, makes sense.
Yeah, I guess like if you see the paper, like they have examples of the interleaved ones, like the generations. So basically, if the data will be the same, but like all, yeah, it's like what it's. I don't know if you saw some of the generation examples in the paper. Yeah, if we had like more, I guess if we had more tweets or something, we could like put it up on the space. But yeah, maybe for next time we should do something like that. But yeah, yeah.
Yes.
Okay. Did anyone? Sorry, was that Aaron?
Oh, nothing. Anyone else? Okay, then I guess we can move.
Let's see. There's some people who are requesting. I'm going to approve a couple people. I don't know. They don't. I don't know if they have questions or what. So I'll just approve a couple people though.
Oh yeah, go ahead.
Hello.
The commute. Can you hear me?
Yeah, I think Sherman was going to talk first. I think.
Oh, okay. Go ahead.
Okay, sorry about that. So
No
for
worries.
so for the Chameleon paper, one thing that I noticed was that it's not at least for table 1 within the Chameleon paper. I suppose they trained for 4 trillion tokens as opposed to 1 and 2 for Llama. For Llama 1 and 2, so Llama 1 was trained for 1 trillion tokens. Llama 2 was trained for 2 trillion tokens. So yeah, I suppose it's not exactly a like-for-like comparison. And also you mentioned that it previously it outperformed Gemini Pro, but I see in table 6, it does not, in fact, outperform Gemini Pro and GPT-4 and GSM 8K Math and MMLU. It actually does perform as well. So I just want to bring that up.
Regarding the number of tokens, I mean that includes the image tokens as well. So I don't know if they have the amount of text tokens versus image tokens.
I see.
But maybe that's also where part of that, yeah, because yeah, it's true. Maybe if they just, I think you're trying to say like if they just trained on more, if they train Llama 2 on more text tokens, then it should be as good as Chameleon or better than Chameleon, right? So, but I think the difference is because of the image tokens too. But I don't know if there was a breakdown of how much of those tokens were image versus text.
Oh yeah,
I'm trying to check.
So,
oh, you did? Okay.
For text-only tokens, they use 2.9 trillion tokens, and for text-image pairs, they use 1.5 trillion text-image tokens, and for text-image interleaved data, they used 400 billion tokens. So most of the data was actually not interleaved, but mostly either text-only or text-image pairs.
Mm-hmm.
That's a good find. Obviously, I want to be able to share the floor with other speakers as well, so I'll try to keep this short. One note for the Gemini 1.5 update, that was only in storage.google APIs. It was not updated on Archive if you're searching for it, just so people know and are searching for it. With respect to the specialized Gemini 1.5 Pro model, that was specialized to math, there was a certain part where it was essentially called, it was evaluated on RM at 256. Do you think this might be essentially evaluated using process supervision, where 256 samples were essentially generated, and then a process supervision model was essentially taking the total probability over all of the different steps within the calculation and basically multiplying them out and selecting the highest, the candidate answer with the highest probability based on the process supervision reward model in order to select the final answer? Is that what you think it is? Because they didn't describe exactly what RM at 256 is in detail. Like how is the candidate answer selected exactly?
Yeah, I think that's a very good point. Yeah, I had the same question. Yeah, I totally agree. I think it should be some combination of process reward model plus self-consistency, like the process you described. I think the important part is that probably so you know, even without that process, the performance is already pretty strong. So I guess I would personally just look at the one without that process, and then they scored 80%, which is very good. So yeah, I guess that's the only number we need to look at. Ideally, we probably don't want to just generate 256 samples for each solution, which is sounds like a very expensive process. And by the way, as self-consistency like approach typically doesn't work for general math or general math question or reasoning question, because typically solutions do not end with like a final answer. like a for proof type question. So yeah.
Yeah, which is why I think process supervision was used instead, because it outperforms self-consistency.
Yeah. Agreed. Is there anything else to discuss?
Not for me, thanks.
Thank you.
I found the post about math. So Technium is the one who's saying that math is the train set is contaminated with the test set. So that's maybe worth pointing out. And he also gave one example of that, and I put one of the examples up on the top here. But yeah, I don't know, that may be something to keep in mind. Yeah. Anyway, Meher, I think you wanted to speak next.
Yeah, I was interested about Chameleon and specifically about its image tokenization. So from the paper, it seems like they're using VQVA, but do you have any specifics on that? Because I think from the paper that they reference, they use different type of tokenization based on if they have a different image or a semantic segmentation map or a face. So I'm just wondering if it's the same thing that they're using in Chameleon or is it something different?
I didn't see anything about that. I know they made one. The only thing I remember about the tokenization specifically was they made a note about it did pour on text, and so they said that it was that was a problem with it, and it was upper bounding their capability in terms of dealing with text in the image. But yeah, I
Wait, so
didn't.
they're having issues with using both image and text tokens at the same time, or
No,
what
no,
is it?
like OCR, like basically like any text in the
Oh yeah,
image. So, because I guess when they train the VQE, it's not able to reconstruct those images very well if they have text on those images. So they were saying that's going to upbound their capability when it comes to, for example, OCR tasks or things like this. So that was one complaint they had. But yeah, I know it did reference the Make a Scene paper, and yeah, I wasn't sure either, but I don't know if they use anything specific in their tokenizer for these sorts of things, and I don't know if they had. Yeah, I don't think they provided any additional details about the
yeah, they're pretty
tokenizer.
moot on the details regarding the image tokenizer. I think
Yeah.
what they're trying to do is just use a regular VQAE.
Mm-hmm.
I'm assuming that for Chameleon, they're not too much worried about the using semantic segmentations and everything, which Make a Scene paper uh, uses in detail. So using these VQAEs, you have these discrete codecs or codex embeddings, and I think they auto-regressively predict that and then put it into their image generation decoder or whatever the decoder that they use to generate these images. I think that's the reason why they've not added so much detail into it because it's so simple. I don't know what are your thoughts on it.
Yeah. Yeah. Yeah, I mean, I agree with what you're saying. I mean, yeah, and I don't know if it's like, yeah, why they don't have more details about the EQB. Well, okay, so like, the Make a State paper actually has a separate, I guess they have a separate sort of segmentation VQVAE, right? It's not like part of the main VQVAE.
Yeah.
So maybe that's so like, yeah, they're just not using that here, and they're just doing the same thing with the regular VQVA. And I think the other part is like I think the other thing was that they were, I think in the Make a Scene one, there was something about it being face aware. And then also in the Chameleon paper, they talk about upsampling the percentage of images with faces. So there's also maybe that's the other thing that they are trying to highlight there, is the focus on faces, which is interesting though, because they talk about that, but then I actually don't see many examples of images with faces in their paper, which is a bit odd. So that's another.
Yeah, I think make
That's
a
a bit
scene
odd,
paper
actually.
it's a bit dated in terms of I think they're using VQ GANs for specifically for faces, and then some modified form of VQVAE, what they call VQ-seg for segmentation. So I'm
Right.
just assuming for the regular scene-based images, the regular images, that you're just using the regular VQVAE and then its discrete codecs from the vector quantizer.
Yeah. 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 Now that I think about it, that's really weird that they talk about this sort of thing about like upsampling for faces and things like that, and then they don't show a single example of a human face. That's actually really odd.
And if I recall correctly, make a scene, their tokenizer was not, their VQVAE was not open sourced. So if I recall correctly, so I don't think we can try it out by ourselves either.
Yeah.
One thing you can try out is there is a seed tokenizer, not related to this paper, but it is also a tokenizer that they've used, and I think if I recall correctly, they were using Llama to make it multimodal. Essentially, add in 32 image tokens along with the text tokens to make it multimodal. So that was working pretty well, and that is open sourced as well. So I wonder how that compares with Chameleon.
I'm just looking for that. That's the one from Tencent AI Lab.
Yeah.
Seed Llama. Yeah, okay, that's cool. Yeah, I think I had heard about this paper before.
Yeah, they were in iClear. So
yeah,
if it underwent, so they use, I don't know if you want to discuss this paper, but in just to brief everyone, I think C tokenizer they used Q formers to convert the feature embeddings, ones that you get from clip, into 1D causal dependency tokens, ones which can be predicted by transformers, the regular LLMs. So in the sense, they're going to be using 32 of these 1D causal tokens along with the text tokens to add that multimodality. And one thing that they noted, the authors of Seed tokenizers were that you have to use the same or similar amount of tokens, like the image tokens along with the text tokens. So if there's an imbalance with that, the model just doesn't perform well with multimodal, even though it might make sense to use a larger number of tokens for images to get a better reconstruction, but you do have to balance it out with the text tokens. So that was pretty interesting.
So is this kind of similar? I mean, so this is doing interleaved kind of generation, or yeah, it's doing interleaved generation, right? So it's also
this
generating.
is only interleaved generation. Like I haven't seen an example where it's pure image.
Okay.
So yeah.
Cool. Cool. Yeah, I'm looking at the paper right now. Interesting. Anything else? I guess there were a couple other people who had. Let's see here. Who else is here? Who wants to speak? I don't know. No.
If there's nobody else, there's another important paper I really want to mention.
Let's see. Someone here may want to speak. I added someone, so I don't know if they want to speak or not.
Oh, okay.
Maybe not. I guess they don't want to speak. Well, let's see who else. There's someone else. Yeah, we had a couple of requests to speak, so I'm just going through that right now. Henok, is that right? Do they want to speak? Hello? No?
Yeah, can you hear me?
Yeah.
Yeah, so about this paper, like I really want to understand the the module that they introduced, the plug and play, like what is it specifically? If anybody can explain that in some clear terms.
Which paper are we talking about?
Sorry, I missed that.
Which paper were you talking about? Plug and play? I don't remember which one this is.
The Chameleon paper.
It's not really plug and play. It's one big transformer that is able to take in text and images and output text and images as well. So I guess I don't fully understand your question. I don't know. Okay. Did anyone else want to speak? The Stellar Drive. Did you want to say something?
Well,
Okay.
I mean, not much today, so yeah. Sorry.
Okay. Okay, then let's move on. What was the next paper, Ari, that you wanted to talk about?
Oh yeah, I want to talk about Oct. Can you put the link? I can send
the Octo paper?
Yeah, Octo paper.
Okay, yes, I will put that up.
I think this is a very important, interesting paper. So firstly, this is an open source, widely applicable generalist robotic manipulation model. And the Oct model is a transformer-based diffusion policy model and pre-trained on 800,000 robot episodes from the OpenX embodiment dataset. So basically, I believe this can be this policy can be used to manipulate humanoid robot or maybe non-humanoid robot. As you know, so the thing is, most importantly, their model Octobase with 93 million parameters, they performs on par with 55 billion parameter RT2X. I think that one is from Google. And yeah, I think that's very impressive, if I understand correctly. So yeah, I think you can just go to the link. They have some visualizations. So I think this impressive performance is because of the use of diffusion training, and the choice of dataset may be very important. So I think this result says that robotic manipulation still has enough low-hanging fruits that such that scaling is not the only determinant of the performance yet. You know, for language models, we almost many different things have been tried, and dataset has been optimized so that a significant amount of performance gain, most of the performance gain can be attributed to things like scaling and some other things. But for robotics, I guess that's not the case yet, because there are just so many other things that have not been optimized yet.
So with this paper, they did like both zero shot and like fine tuning, right? So some of the tests they just did zero shot performance on some of these robotics tests, and then others they had to fine tune a new policy for that particular test. Is that correct?
Actually, I'm not sure if they tried zero shot version, but one thing they said is that their model is trained in a way such that it can immediately transfer to, it can fine tune on whatever target task immediately. So that's their selling point, I guess.
Mm-hmm. Okay. Yeah, I don't know a whole lot about robotics, unfortunately, but it seems very interesting. Yeah.
Yeah, robotics. Well, humanoid robot especially has been showing remarkable progress recently. So I think this is a very important domain, especially for commercial applications. And
Cool.
It's such a compact model. Obviously, it's gonna be scaled up, but yeah, that's something I found very interesting.
Yeah, and this is from like the group in UC Berkeley, right? It's from which lab is this from?
Oh yeah, it's from different universities actually. It's led by Chelsea Fing and Sergey Levin, but from Berkeley, Stanford, Carnegie Mellon, and Google.
Okay, cool. Okay, the next paper we want to talk about, let's see here. I guess maybe the images that sound paper, which I think is an interesting paper. Let me pull that up. Yeah, so I'm just going to share this to the space first. Okay, so with this paper, it's I think it's kind of very creative and unique. Basically, the goal with this paper was to generate spectrograms that actually look like what the spectrogram is, I guess, playing. So, like for example, I guess you could have a dog barking, and so then the spectrogram is supposed to look like a dog barking. And so this was, I thought, very, very interesting, very creative application of diffusion models. So actually, what they did here is this is completely inference only technique, or inference time technique. So they didn't have to create a new model or anything like this to do this. But basically, they had two models. They had a stable diffusion model, and they had, I guess, this. I think it's called off fusion, or I guess like an audio diffusion, off fusion, or whatever. And this is I guess a model that's fine tuned. It's a stable diffusion. I think it's a stable diffusion model, fine tuned on spectrograms, so to generate spectrograms. And so what it means is that both of these models have the same latent space, because with the diffusion, with these both of these are latent diffusion models. They have the image that is actually encoded in the latence, and the diffusion is happening on the latence, and so the latent space is the same. They both use the same encoder to encode into the latent space, which is this VAE, that latent diffusion VAE that was trained by the researchers, the stable diffusion researchers. So they have the same latent, and then they use these two separate diffusion models to denoise that same latent throughout the during inference. And I guess they have to do a weighted average of the actual denoising, because they will produce maybe different I guess output denoise latents. So they have to do a weighted average of the two denoised latents that are produced by the two models, the image model and the audio model. But they're able to do that and eventually get I guess a spectrogram that looks like an image that corresponds to the prompt that you wanted. And then they have a separate sort of decoder that takes that spectrogram and outputs an audio from that. And so that's like a pre-trained off-the-shelf decoder. I guess they call it a vocoder in the audio literature. It's called a vocoder, right? You go from the spectrogram to an actual waveform that you can play. But yeah, that's basically the method, and yeah, I think it's just a very creative task that you can do. I thought it's kind of neat, and so I think there's just so much you can explore with these diffusion models, and I think this is a good example of that. So that's all I had to say about that. Did Aaron, do you want to add anything or any other thoughts?
Oh, nothing in particular. What do you guys think?
Yeah, I guess they're. I'll add a couple speakers here who wanted to talk.
Maybe I don't know if you guys noticed, but it's they use zero shot, the method they use, and that's really quite fascinating about this paper. Like that, it doesn't require like paired training data to, and like it doesn't need anything, and it composes the audio and the visual element without prior examples. So that's like quite fascinating.
Yeah, it's like completely inference only and doesn't need any separate training. I thought that's quite cool. And the reason, of course, is like with the audio model is because it's using the same latent space, I guess, as the as because it's basically, I guess, a fine-tuned a fine-tuned latent diffusion model. Like if you had your own sort of separate audio diffusion, maybe it wouldn't work as well. Like you wouldn't be able to combine these two methods, but because it's using the same latent space, that's the reason you can do it at inference time. But yeah, I think it's quite cool. Anything else that people want to add? Let's see. Okay. Let's maybe move on to what else do we want to talk about. Aaron, what was the next paper to talk about?
Oh, I was going to talk about this paper called MoRA, high rank updating for parameter efficient fine-tuning. But unfortunately, I don't have enough time to sort of go in, read this paper in details. So let me just mention it very briefly. So apparently this paper attempts to do like a high rank version of LoRA, but using like a comparable number of parameters to the original LoRA, meaning the same memory budget. And yeah, they did get some performance boost on some tasks. So yeah, if you're interested, please take a look at it. Maybe it'd be nice if you could sort of copy and paste the name on, and you can show it to everyone.
Oh yeah, it's shared on the space on the top of the space right now.
Oh, thank you.
Cool. Let's see what other papers are on our list. We covered Chameleon, Octo, MoRA. Yeah. Okay. So one last. Oh yeah, two more papers I guess we have. One paper I wanted to cover was CTRLorALTer. Let me put that up on the space as well. CTRLorALTer. This is a paper from the CompWiz group. So that's the same. That's the lab that developed latent diffusion and VQGAN and stable diffusion and all of that fun stuff. And yeah, this is an interesting paper because it's the idea here is basically training a LoRA model that can basically have different forms of conditioning. So they're able to condition based on both structure and style. So that's the interesting thing here. And then you can maybe vary the amount of influence you want to have for the structure and the amount of influence for the style. So I didn't have a whole lot I wanted to say about this, but I just thought it was a kind of an interesting paper that I wanted to point out because it's basically it's outperforming some of these other methods like ControlNet and T2I-Adapter, and it's able to it's also much more parameter efficient, and so they have their comparisons there in the paper as well. And so yeah, I thought it was kind of an interesting thing to and it's also architecture agnostic, so it's not just for like stable diffusion models, but it's architecture agnostic, so it can be used for other types of diffusion models. But I think they present most of the results, of course, with stable diffusion. But yeah, I thought that was another interesting paper just to highlight that as well. And it's from the CompWiz group, which always does quite great and interesting work. But then the last paper I wanted to talk about was the Anthropic paper that was released yesterday. But I guess before we move on to that, I will maybe ask some, or have some people over to ask questions and stuff. Let's see here, who wants to ask questions? I think we have Christopher who wants to maybe ask a question.
Yeah, I was just wondering, the Control-Alter, is that simply by altering the number of the dimension of your low rank adaptation through the linear layers? Is that how that works?
No, they have like a separate architecture designed for in order to be able to I guess there's a LoRa for both style and structure in the same LoRa. Basically, that's what it's doing. Yeah. It has conditioning for both style and structure, so they have a different sort of a new sort of conditional LoRa block that is able to do that.
That's very interesting. Yeah.
Let's see what else. I'm going to accept a couple more people here. And if, yeah, also maybe I might have to remove a few people too. That. Okay. Anybody else wanted to say anything?
Yeah, Finish. I had a question regarding the image that sounds paper.
Mm-hmm.
So in that paper, I just wanted to know, we are providing a textual input for we are providing a we are providing the image as a prompt along with an audio. Let's say for the dog example, a dog barking. But does the model give us the audio output as well, like a new generated audio output as well, or it's just working to generate the image?
So what's being generated is a spectrogram. So it's like a visual representation of the audio. So the output is this spectrogram. That's what the output is. And the output, the spectrogram also, it's like, it looks like some particular image as well. That's the idea there.
But the spectrogram is a different modality, right? How does diffusion take care of generating a different modality by taking input as text?
Well, it's treating this sort of diffusion model treats the spectrogram as a sort of it treats it kind of like an image only. So it's treated it's like you're trading a text. It's like you have a text image model, except the images are spectrograms. Yeah, like it's like people you basically like these models are like the spectrogram generation is like image generation, except it's a very specific type of image, which is these spectrograms. Like a lot of these methods, you can like if you can just treat it as an image, and then for example, if you want to do generation, you can just do image generation. But in this case, it's a spectrogram.
So
I don't know. I don't know if that clarifies it.
Spectrogram correspond to any audio?
Yeah, so the generated spectrogram will correspond to will correspond to audio, and that audio will sound like what you prompted it to sound like.
Got it.
For example, and the example that I show in the top, there was an example of a corgi or something like this, and the spectrogram looks like a bunch of corgis, but when you play the spectrogram, like you can basically what you do is you have a model that can take the spectrogram and generate a waveform. So you play the spectrogram and it sounds like a dog barking. So it's corresponding to that sort of corgi, the dog barking.
Got it. So basically, we are having a single form of output which is representing two dimension. I would say two different Yeah, two different dimensionalities or say modalities, right?
Exactly. Yeah, I think Thunderstorm is raising their hand. Yeah, feel free to speak.
Hello. I'm sorry.
No worries.
Hi, good evening. I like your paper. Did you write it? Did you write it yourself?
No, none of these papers we written. If we wrote any of these all these papers, we'd be very yes, we're not that productive, I guess. No, we were just talking about other papers that we were finding interesting. That's what we're doing here.
Yes,
Yeah,
but
I wish we were that prolific.
okay. The LoRa adapter. You're talking about the LoRa adapter, right?
Yeah, there was one of the papers that was published by the CompViz
Right.
group. They trained a LoRa adapter that kind of captures both the style and structure, and you can kind of generate based on you could generate based on that if you want to incorporate more of the style or if you want to incorporate more of the structure
What
of
does
an image.
Yes, I have read it from abstract on. I think text to image. Oh, that's cool. And is it only with photographing animals, or also photographing buildings, for example?
I mean, you can do. I guess you can train it on whatever you want. They just had the example of animals. They trained their LoRa's on animals, but they have examples of, I think, on you can have different styles from like different painting styles, or you can have the structure of maybe different people. They have different examples in the paper as well. But that was just the one that's just one example they have.
All right, and my last question is, will the LoRa adapter, will that be an option in a computer, or will it have its own name, or will it just be a button like on the computer or on a camera?
Well, this is more for like a text to image generation for generating like AI generation, AI art generation.
Okay. Oh, really amazing. Thank you. I will keep listening to the talk. Thank you very much for answering my questions. Thank you. Thank you very much. Okay.
Yeah, cool. So I think that we'll move on to the Anthropic paper, Aaron.
Yeah, sounds good.
And that will be our last paper to discuss today. Yes, let me pull up the Anthropic paper and put it up. I'm sure a lot of you guys have seen it on Twitter. So with the Anthropic paper, yes, I put it up on the space. Yeah, this is a very interesting interpretability paper. And so this is like continuing research that the Anthropic team has been working on, interpretability, focusing on, I guess, what they call sparse autoencoders, where they are able to extract features from the language model and even and kind of understand which features are being activated when the language model is generating text, and also you can manipulate those features as well, and that leads to different behaviors from the language model. So this is what their paper is focusing on. They had done some previous work with smaller transformers. I think they mentioned, maybe I think the previous paper was on like a single layer transformer or something like this. So yeah, the previous work was very much limited. It was very much for toy models that they were exploring this research direction. But this paper was focusing on applying their approach to a large language model, and in this case, the large language model they're looking at is the Claude 3 Sonnet model, which is Anthropic's medium-sized language model that they have. It's available via the API and everything like this. So it's a quite well-performing language model, and so they apply their approach to that. And so basically, with the sparse autoencoders, the idea is to the whole I guess goal that what they're trying to do is they're trying to take the intermediate activations of the language model and try to kind of understand them into a more interpretable in a more interpretable way. And so they are understanding, the activations of the language model, what those activations may correspond to, what sorts of, for example, topics the language model is focusing on, these sorts of things, and they try to make that interpretable. So the way they do that is they train this sort of sparse autoencoder is what they call it. Basically, they have an autoencoder model that the input of that encoder, the input of the autoencoder is the activations from the large language model. And so they choose, I think, a layer in the middle of the a large language model, and they're passing in the activations from the middle of the large language model into this encoder. That encoder is mapping the activations to a higher dimensional layer, and this is where you get the features from this higher dimensional layer in the autoencoder, and then the decoder is going to take those features and try to reconstruct the model activations from these features. Of course, you want to, so the other thing is that, of course, the higher dimensional layer has a sort of a sparsity penalty on it. So that way they're able to kind of better decompose the activations with this sparsity penalty that they have when they're training this. So they have to train basically a separate autoencoder that is decomposing the activations from the large language model. So they have this model that they have to train separately. And I think they, yes, they are training this sparse autoencoder, and they have done some scaling laws experiments with this as well, where they train at different scales. And then after that, they when they have their trained autoencoder, then they can interpret. They can actually look into these features from the sparse autoencoder and see what sorts of text, for example, gets activated, what sorts of features get activated when you pass different types of text into it. So they have various examples. So for example, they have the I think the Golden Gate Bridge one was the very amusing one, I guess, where basically it gets activated whenever you're talking about Golden Gate Bridge, when you pass in text about Golden Gate Bridge, or when it's generating text about Golden Gate Bridge. It'll get very strong. This feature will get very strongly activated. They have a whole bunch of features that they talk about, and that they give some kind of specific examples. So they had some examples with like neuroscience. There's a feature that is associated with neuroscience. There's a feature that's associated with transit infrastructure. And then the more interesting thing, I think, in my opinion at least, is then you can manipulate these features. So for example, you can set the features to artificially high values, and you can see how that affects the behavior of the model. So basically, what you're doing is then what you're going to do is the approach. What's happening here is like, okay, you're going to take in. You have your language model. You have your activations from the middle of your language model. You pass that into your sparse autoencoder. You get the intermediate features, and you keep all the features the same except for the Golden Gate Bridge one. That feature, you're going to artificially increase that feature, and then you pass that into the decoder of your sparse autoencoder, and then that goes into the rest of your language model, and then you get the output from your language model. And so that is what's happening here. And basically, when you do this, you'll see some interesting behaviors. Like with the Golden Gate Bridge one, if you increase it to like 10 times its maximum max activation or max amount, it starts to act like it's a Golden Gate Bridge. So, for example, if you pass in, what is your physical form? The model responds, I am the Golden Gate Bridge, a famous suspension bridge that spans the San Francisco Bay. My physical form is the iconic bridge itself, blah, 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 blah. So it starts to think it's the Golden Gate Bridge. Another example is if, when you talk about popular tourist attractions, and there's a feature associated with that, then you ask the model, where should I go on a walk around the neighborhood? Just one idea, please. And it starts talking about the Eiffel Tower. It just says the Eiffel Tower is one of the most iconic attractions in Paris, blah, 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 blah. So, that's you can manipulate these features and that affects the behavior of the model as well. And then, of course, they identify, they have also looked at some of the features associated with things like, I guess, more safety-related features, as you might say, with things like bias, things like, what else? They had all kinds of features that they were looking at, safety-relevant features. So they had like things like bias, things like unsafe code, things like deception, power-seeking, manipulation-related features, all these sorts of other features. And so maybe if you're trying to make a more safety-aligned model, maybe these are features that you want to, try to decrease the value of these features or something like this. So maybe there's some interesting safety applications. And that's what Anthropic is trying to investigate, and that's what they're trying to do with these sorts of papers and this sort of research. So, yeah, that's kind of a brief summary. Hope that made sense. Aaron, is there anything you wanted to add about this paper?
No, actually, I didn't read the paper very carefully. So
okay.
Yeah. By the way,
no worries.
Somebody's raising a hand, I guess.
Okay. Let's see here.
Yeah. So, Tanish, I had a question.
Oh yeah.
Regarding this paper. So, from what you have said so far, I got an idea that this is somewhat very much similar to giving a persona or creating an assistant, which we do with the current models, right?
I think it's not necessarily creating assistant. I think because it is very specific to like certain features, right? So like with the Golden Gate Bridge one, for example, it's just going to keep you increase that activation or that feature, and now it's just going to keep talking about Golden Gate Bridge, I'd say. So I don't know if it's like you could really create a persona per se. Like you may have to if you want to create a persona, maybe you would have to do this over hundreds or thousands of features and kind of manipulate all these different features in order to get the persona that you want. So I don't know if that's necessarily something that would work or how that would work. But I think this is much more fine-grained than that. That's my understanding, at least.
Yes, this is at a very model level. So we are actually fine-tuning the model using the sparse autoencoder. But it would be interesting to compare how a base model performs, let's say, we, on a specific, I would say, on a specific persona where we are setting the tone like on you are a Golden Gate Bridge and give the response accordingly, and then maybe we can have a comparison of both the outputs generated from the fine-tuned model and from the base model as well.
Sorry, I didn't catch that. I think you were cutting out a bit.
Sorry, I'm having some network issues. So what I was trying to convey is that we can have a comparison where we set a persona for a base model and as well as for this fine-tuned model where we use this sparse autoencoder and then eventually we can compare the output of this fine-tuned model as well as the base model where we are giving a persona like you are a Golden Gate Bridge and how the output varies of both the models.
Yeah.
to get a better understanding.
Yeah, that's true. That would be an interesting experiment to do. It's possible they may have done that. It's just that I didn't maybe I just didn't catch it. But I don't remember them doing anything like that. I'm trying to check. I don't think they did. But yeah, that'd be an interesting experiment to do. Okay, let's see. Some people want to speak.
And you were speaking about the intermediate activations that they take to process to the sparse autoencoder, right? Do they do any ablations on which intermediate layer works better or something like that?
Which intermediate layer works better? Yeah, I think they
Embedding, yeah.
talked about that. Yeah, I think they talked about that. Let me see. They had a comment about that somewhere in the paper. They said, okay, in this work, we focus on applying SAEs to the residual stream activations halfway through the model, i.e. at the middle layer. We made this choice for several reasons. First, the residual stream is smaller than the MLP layer, making SA training and inference computationally cheaper. So they're saying it's computationally cheaper to choose that middle layer. And then also they say it says help us mitigate an issue we call cross-layer superposition. So there's something about I guess there's some issue with you using other layers. I didn't read too much into that, unfortunately. And then also it says, they reasoned that it is likely to contain interesting and abstract features. So also they just thought it would have more interesting features as well. So it looks like they didn't particularly do an ablation, or at least if they did, they didn't really they didn't maybe show those experiments there, but they did, they had some, I guess, justification at least for why they chose that layer.
Got it. Good.
Yeah. Any other questions?
Yeah. So they claim that the residual stream is smaller than the MLP layer, right? And what does it actually mean?
Yeah, I wasn't entirely sure myself, to be honest. I didn't. Yeah, I have to look into that more, honestly. Yeah. Sorry, I don't know. Does anyone else maybe have a good sense of that? I'm not sure.
Yeah. And how do they identify which feature is for which concept?
Yeah, I think they are looking at they have to they talk about that. They have different prompts that they look at, and then they vary the prompts. But yeah, let's talk about I think more in the end of the paper. Let me see.
Sorry.
Go ahead. You can.
I believe what they did, they used two methods to identify what each feature corresponded to. So the first method they did was to look at which prompts within the data set had the highest activation for that particular feature. And then they sort of, it seems like they just eyeballed it to figure out what exactly it was. The second method they did was for some prompts, they essentially either zeroed out or essentially activated that feature, and they observed how the model's response changed. And those are the two ways they identify those features.
Mm-hmm. Yeah.
Yeah. Okay. Makes sense.
Cool. Let's see. There are two other people here who want to talk. No, I guess not. Okay. If no one else has any other questions, or does anyone have any other thoughts or anything else they want to discuss about, I guess, any of the papers we've talked? Aaron, did you have any other thoughts?
Yeah, go ahead.
Oh.
Yeah, I was going to ask a question real quick because I can tell you guys are very knowledgeable on the AI papers and research. Do you have any advice to people who are interested in finding the state-of-the-art research on a given topic? Is ARXIV the best place to search and maybe train a BERT model for preference or something? Do you have any advice?
Yeah, archiving is typically the best place to, or if you want to just find the latest papers, probably it's easier to just follow a Twitter feed. You can probably just follow whoever I'm following or Tanish is following, or you can just follow me or AK for paper tweets or Tanish. Yeah, maybe it's a bit difficult to just find papers from archive directly. Oh, actually, Google search works surprisingly well. So yeah, you can probably just put some keywords plus archive, and then you get typically like recent papers. Yeah, highly recommended.
And Hugging Face also has some kind of papers of the week, and you can check out what is the state of the art there.
Oh yeah.
Yeah.
Yep, I agree with all of what Aaron said.
Yeah, Tanish, what's up? Can I ask a question real quick before you end it?
Sure.
Yeah, so I saw your space because Parm was in it. We get in our little fights every once in a while, but she's very nice, and I do respect her opinions. But I am sort of the resident extreme skeptic on all things AI, and I'll just, because I know you're sort of wrapping up, so I'll just tell you one reason, and I'm interested in your opinion because I've never spoken to you, and I don't know, you might have something interesting to say. And essentially, it boils down to the tools that we have. I don't think anybody denies this. We have symbolic AI, essentially just deductive reasoning, and we have neural networks, which is just inductive reasoning, algorithmic, predictive, based on training data. We do have cleaner training data. We can collect more data, but as far as I can tell, maybe y'all have something. I would be very happy if you have a very good answer to this. But what tools do we have to go beyond predicting anything to do with a complex system, like anything to do with solving the edge case? Like how is this going to be accomplished? I hear a lot of like words, but I'm very interested in like ways to get there other than, I don't know. I just feel like it may be impossible, and we may be spinning our wheels, and perhaps our smartest minds like you guys could maybe be time better spent. But that's just my opinion. Interested in your thoughts.
I guess I don't fully understand the question, to be honest.
Yeah, so it has to be Turing computable if you want to use training data and neural networks. It's just inductive reasoning. And how are you going to go outside of the training data if the data cannot be collected? One. And two, that's the only tool we have. Even a combination of them, you can't get driverless cars with that. The edge case issue alone trumps that, as far as I know. I'm not an expert, but read a couple books.
Yeah, I mean, I think, yeah, it's true that like a big problem is that a lot of neural networks are, they struggle with extrapolation and mostly focusing on interpolation. But I think also like some of these sorts of like self-play and self-improvement approaches allow some of these models to, they improve upon what they even stuff that they have not necessarily seen.
You mean like synthetic data or something?
Yeah, exactly. Like synthetic data and training on that. I mean, like, I think like even like a lot of these sorts of yeah, there's a lot of things like, yeah, I think like, a lot of this oral approaches are particularly interesting for this. And yeah, I think that's right now the most promising direction for this, but maybe I'm wrong. Aaron, do you have any thoughts on this as well?
I would agree that's probably the most promising. I could give you my opinion, but I'm not going to because it's probably wouldn't even be good. But I think that's sort of like a misnomer, though, because even with AlphaGo, like narrow, super intelligent, wow, it's like so good at AlphaGo. I mean, is that really impressive when you get down to it? Because, I mean, if you change one rule in the thing, it's like a baby. It doesn't know anything. So it never learned anything. It just learned essentially this one phase space, which is like nothing. See what I'm saying? So it's super intelligent until you like have one change, not even a complex to the thing.
Yeah, I mean, I think that has more to do with that was the task that was set for that for that project, I think I don't know if that's necessarily like at least for that specific example of AlphaGo. I'm not sure, but yeah, I mean, I do get your point. I mean, I think it's still kind of an unsolved problem. But yeah, Aaron, did you have any thoughts on this or anything?
Oh no, I don't have much stuff.
Okay.
Yeah, but
I think the
question you
language,
mentioned-
if language there be for AGI, will be based in breast milk, and sound. If you read your Bible, I think that's where the key is.
Okay. Was something,
Just to
someone else
add,
was someone saying something too, I think. Christoph, or I don't know, someone was talking.
yeah,
Yeah, so
yes,
the
Tanish,
guy mentions complex systems, and really neural networks is the best mechanism we have for analyzing complex systems like the type that he's talking about. I speak from a mathematical point of view, as my PhD was on sort of complex systems. And yeah, neural networks do allow you to study, but only stuff that you have the training data for. But what is really interesting is these multimodal models that are extrapolating, logic from one domain to another domain. So I think these are really where AGI is kind of emerging, sort of. This whole idea is that you can extrapolate logic across modalities.
Chris, this is what I never understand, because I know everyone in here has a higher IQ than me. I'm dumb, like I'm a reader, and I know you got your PhD in math, so I know you know the properties of complex systems. They're evolutionary, they're non-ergodic, they're unpredictable. There are so many reasons that you cannot predict it based on inductive reasoning, no matter how much data you have. And this is for stuff like medical. This isn't just like Google Ads. So we need like very high accuracy. Like 90% won't cut it. So I just never understand why I don't get like destroyed when I ask these questions. Like even the EAC guys, like Beth, like they get upset when I ask these questions. I'm like, I just like want to understand where all the money is going towards and like how we're going to get AGI if it's possible.
See, the one problem with our current system is we do not have a continuous learning algorithm, or we haven't got to the point where we can learn from new data and from the everyday world, right? Like the exploration is not there at all. You have a closed system that sits within a server and it just sees our text. It doesn't interact with the world, or it doesn't. If I would like to learn something, I interact with the world and I learn from it. It doesn't have that flexibility, or it doesn't have the luxury to do that. And
But
I
yeah,
feel that's
that's how we're special. Like we're very
yeah.
special. We can reason to the best
But the
answer
moment
based
we
on
have the
behavior.
embodied agents, right, that will change. The moment we have embodied agents which interacts with the real world, because it can explore and find new things, or it can explore, it can exploit as well, right? Like it explores, it exploits, it learns from it, and you have a continuous model that evolves, then obviously you will see those edge cases find out.
Well, it doesn't know what a thing is, though. Like we're gonna have to tell it and label all the data and like
Right
retrain
now
it.
it is no, right now it is because we are training with only text, and yeah, we are slowly increasing the modalities. The more the modalities it sees, yeah, the more correlation it will can build, because you see, right, even from the interpretability paper, the same neuron is able to learn or match across modalities. So obviously it will get that correlation as you build that knowledge from exploring.
Okay, guys.
Yeah, I think this is. We should move on to. I don't know if there's any like last minute questions before we stop for the day.
yeah, Tanish, I had a question.
Okay, quick one.
Tanish, I had a question for you.
For me, okay.
So, yeah, so recently, maybe you might have discussed this, but recently there was a paper called CANS, Kolmogorov-Arnold's network.
Oh yeah.
Have you seen that paper? So basically, that paper is all about it is like showing a new technique which has the potential to replace the MLP, MLP, or I would say the neural networks that we use today. And it was a very interesting read. So I just wanted to know your thoughts on that, because if we have such a change at such a very fundamental level, uh, it totally affects our the way we are building the transformer models right now, the way we are building newer models, any models, because most of the models that we are working on right now in AI are entirely based on neural networks. And if we have a paper, if we have something like CANs,
Yeah.
which is being discovered
Aaron,
recently.
did you have any? I didn't really look into this paper much, but I think Aaron, did you look into this paper?
It's a can of worms.
Yes, I have. It's posted on my. It's pinned on my
I had a look
profile.
at that
You'll
paper.
see.
So basically, what it does is you have a MLP, you have some, you have a weight, right? What they did is instead of having a constant or a trainable parameter, they have a trainable function there. They just replace that parameter with the function
Oh, is that
in the
Yeah. So
linear,
you,
yeah.
column?
so if you
Yeah. What,
sorry.
Aaron? What were you saying?
Oh, that is a CAM paper, right? From 2 weeks ago.
Yeah, the
Yes, yes.
Kolmogorov Arnold networks or something like this, right?
Yeah.
Yeah.
Yeah. Aaron, did you have any thoughts on
So in
it?
that paper, it is
Oh no,
mentioned.
sorry, I don't have.
It is
Oh,
Oh,
also.
you don't. Okay.
so only thing I think I know is that there have been many papers like that. Well, since the very beginning of neural net, and but we have sort of converged into our current format because in that particular case, I think the training of the model was very slow, at least like 10 times slow or something, and maybe not 10 times, but significantly slower. So my guess is that when you increase the model size, like compute budget, then probably the performance in terms of performance compute trade-off, it may not be as good as neural network, or maybe it doesn't even matter or something.
Yeah, I totally agree. So in the paper, it was mentioned that the computing cost and the computing time is a factor to consider. But if you look at the accuracy, it also says that it was 100 times, I would say, better accurate. It's literally written there. It's 100 times accurate than a normal NLP that we currently use today, MLP that we currently use today. So maybe in the future, if we have better compute, this might be an option. But right now, as you mentioned, with the current computation that we have, MLP is the way to go.
Yeah, I guess we don't. Personally, I don't pay much attention to it until somebody actually show it that it outperforms significantly on larger compute scale. It shouldn't be too hard to do it. So yeah, let's hope that others do it in a larger scale.
Cool. I think last person who wanted to say something was David, and then I think after that we'll stop the space.
Oh yeah, thanks. It's been kind of a while since the Anthropic paper, but I was just going to mention that I particularly enjoyed the code bug feature, which showed where in the code the bug was um, when you kind of looked at the heat map. And if amplifying that feature made the model output some kind of trace back or something for that bug. Um, and yeah, about KAN, I think we already have like GPT-2 with KAN, although I don't know the performance of that. I guess, well, I think we already have something trained, but I haven't really looked much into that. But yeah, I'll be waiting on those results for KAN in general. But yeah.
Cool. Well, yeah, thank you, David. And I think with that, we will end the space. But thank you, everyone, for joining. Aaron, is there anything last thoughts you have?
Yeah.
Any last things to say?
So I think this was a success. Well, at some point, the number of people in this space was like 120 or something, which I haven't tried space before, so I don't know whether it is a good number or not. But that sounds like
I think it's a good number. Yeah.
Okay. How many people do typically attend Thursday space?
Oh, that is. I think that can also. That's more like maybe a few hundred, but I mean that's been around for a while though, so that's a difference. It's like we're doing this for the first time.
Oh yeah, that's a that's a good number then. Yeah, let's keep doing it. Like maybe we can probably do it weekly because there aren't many good papers to discuss every day anyway.
Yeah, that's right. Yeah.
Yeah,
but hopefully people found this interesting, and hopefully people learned something from the space. So yeah.
Yeah, and from the next time, hopefully we're gonna do like stream stuff so that we can show the images and screen to better.
Yeah.
Also, if possible, Tanish, maybe next time you can also share the papers that we would be discussing. So maybe we'll have a better idea, and we would be able to relate a much more better way.
Sure. Yeah.
Of what you.
Yeah, we can like post a list of papers maybe in advance or something like this. That's something we could probably do. I mean, Aaron and I literally decided to do this like 2-3 days ago. So this is like very new for us, and we're just exploring. But yeah, thanks for the suggestion. Yeah, cool. With that, I will end the space. Thank you all for joining. Bye.